All right, let's get right into it. We are going to pull back the curtain on one of the most universal human experiences out there, that absolutely miserable morning after a really, really good night. But here's a thought. What if that feeling, that crash, isn't a bug? What if it's a feature? You know the feeling. We've all been there. That incredible wave of euphoria, excitement, just pure pleasure, only to be followed by this pit of anxiety, exhaustion, and maybe a little regret. It feels like some kind of cruel joke, right? A cosmic tax on having fun. Well, what if this entire cycle isn't random at all? What if it's the result of an ancient, incredibly powerful, and very deliberate mechanism that's hardwired deep inside your skull? Today, we're going to break down exactly how that system works. So, to understand the crash, we first have to talk about the price of pleasure. And it all starts with your brain's obsession with one simple thing: balance. Now, this right here is a total game changer. For decades, scientists thought pleasure and pain were on completely separate circuits in the brain. Turns out, they're not. They are two sides of the very same coin, processed in the exact same neural real estate. And that discovery, well, it's the key to everything we're talking about today. I want you to picture a seesaw, or maybe a classic balance scale, right inside your head. Your brain's number one job, above almost everything else, is to keep that scale perfectly level. This drive for equilibrium is called homeostasis, and it governs everything from your body temperature to your mood. So when one side goes up, you can bet your brain is going to do whatever it takes to bring it back down. So how does your brain actually restore that balance? Well, neuroscientist Dr. Anna Lembke has this fantastic analogy for it, and it involves these tiny, invisible gremlins. So imagine you do something fun. You eat a great piece of cake, you get a bunch of likes on social media, you have a drink with friends. Your brain releases a little squirt of dopamine, and the pleasure side of your internal scale tips down. But your brain does not just let that happen. It immediately sends out these little gremlins to hop on the pain side of the scale to level it all out again. Now, what's really fascinating here is what these so-called gremlins are actually doing. In scientific terms, this whole process is called neuroadaptation. Your brain is literally adapting to that flood of dopamine by making itself less sensitive to it. And this is just a brilliant way to understand how it works. Your nerve cells have these receptors. You can think of them as docking stations, where dopamine is supposed to land and deliver its message. To reduce the signal, your brain just pulls those docking stations inside the cell. So even if there is a ton of dopamine floating around, it has fewer and fewer places to land. It's an incredibly clever and efficient way to turn down the volume on pleasure. Okay, so the brain sends out these gremlins to restore the balance. Simple enough, right? But this next part, this is the entire reason hangovers and comedowns exist. This is the critical piece of the whole puzzle. You see, those little gremlins on the pain side of the scale, let's just say they're a little overzealous. Their mission isn't just to make things level again. They have a really bad habit of going too far. So here's the absolute key. The brain doesn't just bring the scale back to level. It pushes right past level, tipping the scale an equal and opposite amount over to the side of pain. That initial pleasure high is always followed by a dip below your normal baseline. It's a law of the brain. And you can literally see this flip-flop in your brain chemistry. During the high, your dopamine is elevated and your stress hormones, like cortisol, are suppressed. But during the crash, it's the exact opposite. Dopamine plummets way below your baseline and your stress systems go into total overdrive. It's a complete neurochemical reversal. That overshoot, that tipping of the scale into a state of pain, that's it. That is the hangover. That is the come down. It's not some separate event. It's the direct, predictable, biological consequence of the high. It's just your brain temporarily stuck in what's called a dopamine deficit state. And we can actually see this happening. On the left, you see these brain scans of healthy controls, with lots of dopamine activity showing up in red and yellow. But on the right, you see the brains of people with addiction. And, well, the color is almost gone. This shows a profound dopamine deficit. And here's the real kicker. These scans were taken 2 full weeks after they stopped using. That overshoot isn't just a fleeting feeling. It can become a persistent state. Now, this whole system seems kind of badly designed, doesn't it? I mean, why would our brains evolve a system that guarantees we feel bad after we feel good? Well, it turns out this mechanism was once a brilliant survival tool. The answer doesn't lie in our world of today, with delivery apps and streaming services. It lies in the world we evolved in, A world that was defined not by abundance, but by brutal, unforgiving scarcity. Think about it. In a world where your next meal was never guaranteed, being satisfied was actually dangerous. This pleasure-pain overshoot made sure that after the brief pleasure of, say, finding some food, you'd quickly enter a state of wanting, of craving. That deficit state is what motivated you to get up and hunt again. It made us relentless, forward-striving creatures, perfectly adapted for survival. And that right there is the fundamental problem. Our brains are basically running ancient software in a modern world it was never, ever designed for. That brilliant survival mechanism is now being hijacked by our environment. You know, our brains evolved for a world where reward came only after immense effort. Hunting, foraging, building. Now, we live in a world where these incredibly potent, dopamine-rich rewards are available instantly, with just the swipe of a finger. Our ancient pleasure-pain balance is being triggered constantly by things our ancestors couldn't have even dreamed of. So, let's recap. We've learned that every high has a corresponding low, an overshoot into pain, all because of an ancient survival mechanism that's totally mismatched with our modern world. But that brings us to the final and most critical question. What happens to your brain, to your baseline level of happiness, when those little gremlins stop being temporary visitors and they start setting up permanent camp on the pain side of your scale? That's what we'll explain tomorrow.